Okay, so enough from me. Let's get started with our first speaker, and I'm delighted to welcome Andrew Zignani from ABI Research.
Okay, well, thanks, Steve, for the wonderful intro, and good morning, good afternoon, and good evening, everyone. My name is Andrew Zignani. I'm a research director for ABI Research's Strategic Technologies team. As part of this role, I head up our coverage on wireless connectivity and location technologies, including the indoor and outdoor positioning markets. And today I have the pleasure of being able to share with you some of our latest insight into the real-time location, or RTLS, market, with a strong focus on the market trends and opportunities for RTLS within industrial and manufacturing environments, which of course is one of the key driving verticals for location technologies today. So just to do this, I'll first give a brief overview of some of the pain points being faced by industrial and manufacturing facilities and identify how RTLS can help to address some of these via specific use cases. Secondly, I'll focus on what technologies are capable of addressing these pain points and what are the key considerations when choosing an RTLS technology for these environments. I'll then go on to highlight the overall market opportunity for RTLS within these sites, discuss some of the challenges facing adoption, and provide some recommendations on how these challenges can be solved to help accelerate adoption. And then finally, we'll discuss some specific case studies and also talk a little bit more around 5G positioning and its relationship with RTLS, which of course is a very hot topic at the moment and will remain so in the next few years. But first, just to set the scene a little, I wanted to talk a little bit more broadly about the location industry and identify some of the key industry trends impacting this space. Firstly, it will come as no surprise, really, that there's historically the RTLS market has been relatively complex and highly fragmented. There are well over 500 companies actively addressing this space, often with their own proprietary hardware and software solutions, which has made it quite difficult for industry decision makers to select the optimal technology for their enterprise. And alongside this complexity, various cost prohibitors, infrastructure complexity, and deployment challenges have also meant that the majority of enterprises within these key verticals have not yet adopted RTLS technologies at scale. And those who have adopted the solutions have struggled to move it beyond those pilot deployments and scale it up to their wider processes across entire facilities. And in part, I think this is down to what I call almost an obsession within the RTLS industry of the emphasis of accuracy of a technology versus its ability to be deployed at scale, deployed easily, cost effectively, and also on reliability. And I think what's been lacking somewhat to date has been a kind of unified open location ecosystem that can address all of these enterprises at scale. And again, adding to this complexity is the kind of ever-changing technology landscape, with existing technologies continue to evolve, others emerging on the scene, such as 5G positioning, which we'll talk about later. But nonetheless, as the charts on the right-hand side of the slideshow, at ABI Research, we believe that there's an enormous potential for RTLS technologies on the market, and we view it somewhat as almost as a greenfield opportunity that's expected to accelerate rapidly over the next 5 to 10 years, with total RTLS revenues expected to exceed $40 billion by 2030. But what's really driving the need for RTLS technologies, specifically for industrial and manufacturing firms? So as this slide shows, there are a number of political, economic, supply chain, regulatory, and technology-related challenges facing these environments today. And this includes, of course, ongoing trade disputes, periodic lockdowns due to COVID in key manufacturing areas, as well as the ongoing conflict in Ukraine, which are obviously disrupting supplies of raw materials and impacting staff safety. Alongside this, you have high inflation, energy and transportation costs, which put additional strain on margins and impacts greater demand. Wider supply chain issues require increased diversification of suppliers and more effective inventory management, alongside outbound issues that require better tracking of finished products. In addition, you also have these new regulations requiring manufacturing environments to operate much more safely, have more stringent compliance procedures, and operate much more sustainably than ever before, while difficulties in attracting new personnel make it more vital than ever to improve the overall staff efficiency and processes. And these factors are all leading towards manufacturing environments investing more in wider digitization. And these efforts, of course, include things like enhanced supply chain visibility, improved and automated compliance, greater optimization of labor resources and automation of the workforce, improving yields through quality assurance and avoiding errors in production, alongside wider process optimization via digital twins, which enables enterprises to have much more greater visibility of their entire operations and drive new efficiencies. And it's important to know that RTLS technologies are fundamental enablers of all these digitalization efforts. So what does all this mean in terms of actual problems being faced by enterprises today? Well, this slide highlights some of the common major pain points across manufacturing and industrial sites. And these are areas in which RTLS technologies are already being deployed at scale today. And as you can see, these have just been grouped into 6 major areas, all of which are closely linked to the digitalization efforts I just mentioned. So, for example, RTLS is commonly deployed to enhance the safety of staff, personnel, and visitors. Staff can be equipped with tags, clothing, or devices, and then tracked in real time to identify their location, whether that's in remote environments or in emergency response situations, if they've stopped moving or have fallen, or if they've entered a restricted or hazardous area, if they're in close proximity to a moving vehicle, or to enable things like contact tracing or enforce social distancing and more automated and accelerated employee mustering capabilities. RTLS, of course, can also help to track assets, tools, and equipment, helping to prevent theft, reduce search times, ensure materials are stored in the right conditions, and speed up any reaction times to any incidents that happen on site. They can also, of course, help to reduce and minimize production errors and ensure greater compliance. So by tagging tools, assets, and workers, RTLS can ensure that the right tool is being used by the right person on the right component at the right time, and that tool has been calibrated or maintained in the correct manner. So alongside reducing costly errors, this can also help to automate the whole compliance experience and have a digital record of activities on the factory floor. And of course, it can also drive and lead to a number of other operational efficiencies. So this includes things like route optimization, indoor navigation, and task guidance for personnel, identifying any potential bottlenecks in production, and more efficient inventory management, which is of course critical today. And this can apply also to intralogistics applications to help optimize things like yard management, vehicle utilization, which maximizes the overall resources of an enterprise. And alongside this, RTLS is fundamental to these various Industry 4.0 trends, such as predictive maintenance, collaborative robotics, AGVs control and navigation, as well as things like augmented reality and digital twins. And of course, this list isn't meant to be exhaustive. There are hundreds of potential use cases for RTLS within manufacturing environments. And it's often the case that once deployed, that new use cases and optimizations can be found as the RTLS deployment drives greater visibility. But I don't want you just to take my word for it. So over the last few years, ABI Research has conducted a number of different industry surveys on RTLS that identifies key pain points across manufacturing, industrial, logistics, oil and gas, and other enterprises. And as the chart on the left shows, these facilities face multiple different pain points with tool and equipment tracking and asset and material tracking, often the most common pain points being faced in these environments, followed by safety incidents, indoor navigation, and personnel tracking. And of course, as the diagram from the right-hand side shows, from Omlock shows, many of these pain points are closely linked together, and having an RTLS deployment that can move beyond single function use cases to deliver on all of these pain points using the same infrastructure can drive much faster return on investment and also deliver much greater value to these enterprises. But how do industries then decide what technology is best to address these pain points? So as this slide shows, there are a number of different indoor technologies, indoor location technologies on the market, each with their own respective strengths and weaknesses. Again, it's not meant to be exhaustive, and different RTLS vendors have their own specific implementations that may differentiate on things like accuracy, range, battery life, and other metrics. But Bluetooth, for example, is a very popular RTLS technology thanks to its affordability and lower power consumption, with accuracy typically in the range of several meters. There are some sub-meter level solutions available, but Bluetooth can sometimes struggle in the more harsh industrial environments, and there are some concerns from enterprises around interference in the 2.4 gigahertz band. However, it does have some benefits in interacting with things like BLE-enabled smartphones and industrial HMIs, which can be another benefit. Of course, Wi-Fi is a popular technology thanks to the ability to leverage existing Wi-Fi OT infrastructure. But this often has more limited accuracy, has typically higher power consumption, and can be more costly as well, which leads to BLE and ultra wideband in particular being much more supported in the industrial space. And as I touch upon, ultra wideband is a very key technology for RTLS within manufacturing environments. Again, mostly due to its ability to provide very high accuracy, low latency positioning for more stringent RTLS use cases. And I think what is key about ultra wideband is it also has strong performance in multipath environments, and really can perform well in harsh industrial arenas. Sometimes, however, that's part of the downside that it can be more complex to deploy and it can be more expensive than some competing technologies. And just very briefly, I'll just touch upon a couple of other technologies. So passive RFID is used more for inventory management, but not necessarily suitable for real-time location, while active RFID solutions are normally expensive and less accurate compared to the competition. Again, vision and camera-based solutions do exist. However, these come with privacy concerns, and also emerging technologies like 5G positioning, which have strong potential, are still very much in the early stages of development and can't really compete at the moment in terms of key metrics such as cost and battery life. But again, decisions will need to be made ultimately on a number of factors, like which we'll discuss in a few moments' time. So if you look at the manufacturing market dynamics more specifically, typical use case requirements can vary depending on what's being tracked. For example, asset, tool, or equipment tracking, this can be often 3 to 5 meters with less stringent latency requirements. Then you have things like worker and personnel tracking or forklift tracking, which can be 1 meter and more medium latency. And then beyond this, of course, you have much higher precision or safety critical applications, which may require sub-meter level accuracy with ultra low latency between 10 to 100 milliseconds. And this can help to facilitate new applications such as collaborative robotics, AGVs, augmented reality, and mission critical use cases. Therefore, we see that high accuracy, low latency, and perhaps most importantly, reliability of the solution will be critical in deciding what technology to adopt in these environments. And strong emphasis needs to be placed on the performance of these technologies in multipath and harsh industrial environments, which is why we expect ultra wideband to become the leading technology for most use cases, followed by BLE for less stringent asset tracking deployments, and with the potential for 5G positioning in the longer term. Again, as we mentioned, each facility will have its own unique requirements and considerations when choosing a technology. And we've grouped these broadly into 5 major areas. Firstly, of course, you have the technology and performance metrics. Decisions, not only need to be made on what level of accuracy is required, but also the latency of the solution, the battery life, and perhaps most importantly, the reliability and robustness of the solution. Yes, it's great if the solution is centimeter level accurate, but if you can't guarantee this 99.9% of the time, it's effectively worthless. There's, of course, many different cost considerations as well. That could include tags, anchor points, gateways. It could be the backhaul connectivity, the cabling costs, the cost to install the solution, as well as maintenance through staff, battery replacement, and IT integration. And then, of course, you have to pay for the location software on top of that. Installation, deployment, and complexity are also key considerations. So how difficult is it to get the actual solution on site and configure it effectively? How long will it take and what expertise does this require? And how easily can you integrate that with the existing IT and OT infrastructure and data interfaces? And of course, you also have specific site use cases, site and use case considerations. So, what's the deployment environment like? Is it a harsh industrial site with lots of interference? Are there lots of metallic objects and moving parts? Is it indoors or outdoors, or is it both? How many assets do I need to track? How often do I need to track them? Do I need to support multiple different types of asset? And of course, there are many other considerations. So, this can be things like the capabilities of the software. Does it do more than just provide a blue dot? Can it generate deeper analytics and insights into operations? How quickly can the ROI be delivered? Is it future-proof and scalable? What's the reputation of the vendor like? And do they offer aftermarket support? All of these need to be considered when choosing RTLS solution and vendor. And again, it's clear that there's unlikely to be a one-size-fits-all technology that can effectively address all of these requirements for every single use case. So moving on to the overall opportunity for the market, as the charts on the right-hand side show, we expect a significant acceleration of RTLS adoption within industrial and manufacturing environments over the next 5 to 10 years. Firstly, it's a market with many pain points that can be addressed by innovative RTLS technologies that continue to evolve, the value of which has been demonstrated across many different case studies and trial deployments. And we believe that many of the key barriers to wider deployment end up finally being removed as well. We also expect there will be an increased adoption of resilient and high accuracy technologies such as ultra wideband, which we expect to be the fastest growing technology, achieving around a 26% CAGR between 2022 and 2030. So overall, ABI Research forecasts RTLS revenues in industrial and manufacturing environments to grow to over $11 billion by 2030, driven by asset tracking, people tracking, vehicle and equipment tracking use cases. And of course, to achieve this growth, there are still a number of challenges that need to be overcome. And a number of these hurdles have prevented the market from reaching its true potential to date. This includes things like technology choice and fragmentation, limitations in the technology and difficult deployment environments, operational and maintenance costs, the complexity of deployment, as I touched upon, high cost of hardware and software, and difficulties in scaling up from the existing pilot deployments. And this is often due to lacking, company-wide buy-in or future-proof digitization strategies as well. And just to briefly back this up from the industry itself, another finding from an ABI Research industry survey of over 200 enterprise decision makers found that 87% of respondents hadn't yet deployed RTLS. And as you'll see from the blue bar chart, the number one barriers to deployment included tech fragmentation, these operational and maintenance costs, tech reliability, and the complexity of implementations, among several others. So finally, given these challenges, why are we so optimistic at ABI Research that the market is ready to flourish? And what should enterprises do to help accelerate the adoption of RTLS solutions? Well, firstly, we believe that enterprises should take advantage of the new availability of hybrid tags and anchor points to help provide site-wide coverage and support multiple different use cases via a single infrastructure. And this allows enterprises to deploy more flexible, more scalable, and cost-effective deployments that can address both indoor and outdoor use cases. And you see some examples on the right-hand side, which include ultra-wideband and BLE hybrid tags, combinations with LoRa and GNSS, and also the potential for short-range wireless and 5G combinations in the future. Industries should also try and leverage, new automation tools such as distance measuring tools, LiDAR, AI, and remote configuration to help try and reduce the complexity and cost and the speed of deployment. And one of the challenges of RTLS today has been, the need for vendors to deploy engineers and configure on sites for long periods of time. And if these are booked up, it's difficult to provide these solutions at scale. And this obviously was exacerbated during COVID restrictions and lockdowns. And of course, vendors should take advantage of improvements in anchor point range and reliability to reduce the overall infrastructure costs. As the market scales, of course, as well, hardware and the tag costs are also falling considerably, while the availability of more tailored and specialized solutions as well, such as tool tracking tags, vehicle tags, helmets, alongside size reductions and battery life enhancements are all driving this innovation forward. The industry should also leverage, wider innovation in wireless infrastructure. So the arrival of Wi-Fi 6, Wi-Fi 6E, Wi-Fi 7, of course, and in the future 5G deployments will help provide a much lower latency backhaul and much more streamlined deployment of location services more broadly. And again, we believe that there's a need to move away from these kind of more proprietary silo deployments to more open multi-vendor ecosystem approaches that can more effectively integrate with existing ERP systems via open APIs. And this helps, solve some of the integration challenges I mentioned. And we believe, of course, that the software should be capable of providing more than just location and maximizing the return on investment via better analytics and generating these valuable insights on production processes which can be tailored to individual premises. And I think a key point here I'd really like to make is that both vendors and the industry need to be realistic on what level of accuracy is required. We need to really kind of move beyond this, purely performance-driven, everything's about centimeter of accuracy, to really focusing on, what realistically can be deployed and can it be deployed at scale, focusing on ROI and greater emphasis on total cost of ownership and reliability. And again, of course, as industries, there needs to be, a fundamental component of the 4.0 strategy. We need to plan effectively and align with existing and future production processes for RTLS to make it a fundamental component of the future solutions. And again, very finally, the industry should also take advantage of new pricing models, business models that are tailored or suited to facility needs, and which can help deliver the most effective ROI and attract greater buy-in across the enterprise. And this could be coverage based, it could be tag based, it could be insight based, or as a service models which are emerging as well to help support this. I'll now hand it back over to Steve to discuss some specific industry use cases, and then wrap up later on 5G positioning and some other case study deployments. But that's all from me for now.